Hello, 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 and welcome to Problem Set 7.5 Video Key Adding and Subtracting Rational Expressions. So first, some review of how to just deal with fractions that have numbers only. We have 3 elevenths plus 4 elevenths. That is equal to 7 elevenths. Coming over to B, we got 7 sixteenths minus 3 sixteenths. Hopefully you know that that is 4 sixteenths, but you can reduce that to 1/4. So sometimes when you add or subtract fractions, your final answer can be reduced, and sometimes, like in example A, it cannot. So you should always check for that. Now part C is not as simple because you can't just add 1/2 and 1/3 directly. Remember how you have to get a common denominator? So to get a common denominator here, I'm going to multiply top and bottom of this fraction by 3 and the top and bottom of this fraction by 2 so that they both have a denominator of 6. But remember, for a fraction, if you multiply the bottom by something, you got to multiply the top by the same thing, because really I'm multiplying by 3/3, which is equal to 1, which doesn't change anything. Over here, I'm multiplying this fraction by 2/2, which is equal to 1, which doesn't change anything. So our first fraction becomes 3/6. Our second one is 2/6. Now we can add 3/6 and 2/6 to get 5/6. So that's the process of finding a common denominator. Coming over to D, we got to do the same thing here. I recognize that the common denominator between these two fractions would be 30. So I multiply the top and bottom here by 2, and top and bottom here by 3, giving me 28/30 minus 27/30, which total is 1/30. Okay, so that's how you do with numbers. So number 2 says, in general, what do you need to do when adding and subtracting fractions? You need to get a common denominator. You need to find a common denominator. So number 3, suppose you're required to add or subtract 2 rational expressions. How would you go about this? So stuff that looks like this, or this, some more complex ones. But the answer is the same. You need to find a common denominator. No, don't cut that. All right, so on number 4a, we already have a common denominator. Look at that. So 5/x plus 6/x is simply 11/x. Okay, on B, we don't have a common denominator. So let's find one. We have 4x and 5x. So since they both have x already, and that is part of the denominator, we just really need to change the 4 and the 5. So if I multiply this fraction by 5 on top and bottom, and multiply the second one by 4 on top and bottom, then that'll create 25/20x plus 24/20x. And now I have a common denominator, so I can combine those bad boys and get 49/20x. And if you found the least common denominator, this answer will always be simplified already. So I could have found too big of a denominator, and then this would be reducible at the end. But this, as long as you find the lowest common denominator, this will never be reducible unless the original problem could have been reduced before you started doing anything. But remember how, like, we can't cancel this 5 and 5 because this is an addition problem. You can only do that in multiplication problems. Let's jump down to D here. All right, now this is a whole factor, and so is this. And so what you can do here is multiply each fraction by the other fraction's denominator, well, factors from the other denominator that are missing. Here we only have one factor. This does not have a factor of x plus 5. So what we're going to do is multiply top and bottom by x plus 5. Let me get rid of this d right here so I don't have to rewrite the problem. So we multiply this by x plus 5 on top and bottom, and multiply this by x plus 4 on top and bottom. Now the nice part is we don't actually have to do anything here. We just write that, keep that in factored form. So it's x plus 5 times x plus 4 on the bottom. And the top for now is x plus 5 times 3. And then we say plus, let's keep that blue actually. And we go plus 10 times x plus 4. And yeah, you could write this 3 over here. It doesn't matter. You could write x plus 5. Like you could switch the order of these two things. Like x plus 5 could be on this side if you really wanted it to be. And now we multiply our denominators together. X plus 5 times x plus 4. Okay, now we have the same denominator for both fractions. So we can add them together. But when I add them together, I'm going to leave these in factored form, but I'm going to distribute these as I add it together. So the blue fraction is 3x plus 15 on top. The green fraction is 10x plus 40 when I do distributive property. But all that is over the common denominator. You don't have to do anything to that. You just leave it x plus 5 times x plus 4. Just like up here when we did examples with numbers, like 3 11ths plus 4 11ths, this is just 7 11ths. You don't do anything to the denominator, it just stays 11. So same thing's going on down here. But now in our numerator, we can combine like terms, giving us 13x plus 45 over x plus 5 times x plus 4. Like that. And that's our answer. Okay, let's do the same thing over here. Now we have a subtraction problem. Oh, whoops, I forgot to do C. Let's jump back up here to C. I knew there was a subtraction problem somewhere. But this is, we already have a common denominator, so you just do 7 minus 2 and get 5 over x plus 2. Okay, so subtraction problems, you got to do the same thing. You got to get a common denominator. So let's jump down to this subtraction problem. And we got to get a common denominator again. So just like this last problem, we're going to find factors of the first one that the second one doesn't have, and vice versa. So this has a factor of x minus 3. This doesn't. So we're going to multiply top and bottom of that of the first one by x minus 3. Now this has a factor of x minus 3 on the bottom, but this is missing a factor of x plus 2. So multiply top and bottom of this by x plus 2 and x plus 2. So now we have 5x times x minus 3 on top. I just wrote the 5x first because that's how we normally see it. And then the denominator is x minus 3 times x plus 2. Then we have minus 7 times x plus 2 over our common denominator, x minus 3 times x plus 2. So we're done with the denominator. Now we just multiply the numerators. So I'm going to distribute 5x squared minus 15x. Sorry, we don't multiply the numerators themselves. I'm multiplying inside of this numerator, and then I'm going to multiply inside of this numerator. Now notice this minus sign here. That messes things up a little bit. So we're going to do minus, and then everything from this other numerator needs to go in parentheses. So it's going to be 7x plus 14. Because this minus sign needs to get distributed down here. Okay, and then all of that is still over our common denominator, x minus 3 times x plus 2. So we have that. And now distribute the minus sign. So you get 5x squared. That's just this. That stays the same. Now this becomes minus 7x. That can be combined with that. So it's minus 22x. And then minus 14 when you distribute the negative sign. Over x minus 3 times x plus 2. And there you go. That's what you do. All right, moving over to F. This one's actually a little easier because this one has x squared and this one only has a single x in it. So all we have to do is multiply this one by x over x. and that will give us 4 over x squared, that one didn't change, plus 12x over x squared. And now we can add these as 4 plus 12x, keep the denominator the same. And yeah, you can write 12x plus 4 instead. That's how we would normally write it, probably like in standard form. But you don't have to either, it's okay. And there you have it. Okay, so that one's a little easier. All right, number 5 says in order to figure out the common denominator, sometimes it's necessary to factor first. After factoring, we're going to do what we did up here, which says multiply each fraction by any missing factors that the other fraction has already. What that means is like what we did right here. This had a factor of x minus 3. This didn't, so we multiplied this one by x minus 3. This had a factor of x plus 2. This didn't, so we multiplied this fraction by x plus 2 over x plus 2. And then part 5a says typically after combining the fractions, leave the denominator in factored form, which we did up here, but distribute in the numerators and combine like terms in order to simplify. And that's what we did up here as well. So that's like what we did from here to there and from here to there. Okay, let me actually make this pink to match up with the step from above. All right, so now, same thing we were just doing, except an extra step where we had to factor first. So this is 9 over x plus 3 times x plus 2 plus 2 over x plus 2. This has a factor of x plus 2, and so does this. So we're cool there, but we need an x plus 3 on this one. So all we have to do is multiply top and bottom by x plus 3 over x plus, so multiply by x plus 3 over x plus 3, leaving us with 9 over x plus 3 times x plus 2 plus 2 times x plus 3 over x plus 2 times x plus 3. Now remember, these denominators are actually the same. It's multiplication, so the order that I wrote those things is not important. So now I'm going to distribute the 2x, or the 2, and that leaves me with 2x. Then I'm going to get plus 6, but I'm going to add this 9. So 2x plus 6 plus 9 is plus 15 over the common denominator, x plus 2 times x plus 3. Or you can say x plus 3 times x plus 2. That does not matter. There you go. Okay, move that over a little bit. All right, on B, again, we're going to start by factoring. So we have x plus 4 over x minus 4 times x minus 8. And then it's plus 3x over x minus 8. So again, this one has a factor of x minus 8, which this one already has. So we just need to give this one a factor of x minus 4. So multiply top and bottom by x minus 4, like that, leaving us with x plus 4, so the first fraction stays the same. And then plus, I'm going to distribute on the top right now. So I get 3x squared minus 12x when I distribute over our common denominator. I'm going to write it in the same order this time, x minus 4 times x minus 8. And now we just combine like terms in our numerator. So now I have, oh, that's too late. Now we have this x and minus 12x squared. And those are the only like terms, actually. So it ends up being 3x squared minus 11x plus 4 all over x minus 4 times x minus 8. Whoa. Don't know what happened there. All right, there you go. Okay, now on C, again, we're going to factor everything first. The first one's already factored, so that's nice. Second one, we have a GCF of 2x. So we're left with x minus 2. All right, now this one gets a little messier than the other ones. So this one has a factor of x squared. This one only has a factor of x. So we need to multiply this one by x. This has a factor of 7, and this one doesn't. So we're actually going to multiply this by 7x on top and bottom, like that. Now this one has a factor of 7, but not a factor of 2. it already has an x built into it, like this x already exists here, but it's missing the x minus 2. So now we have to multiply top and bottom by 2 times x minus 2. Like we got to multiply it by 2 different factors, and you can just do it at the same time like this. So look what that's going to do. When I do 2 times 7, I get 14, x squared times x minus 2. Over here, I do 2 times 7, get 14. X times x is x squared and x minus 2. So I did get a common denominator. And then we got to multiply all this together, and we got to multiply these together. So now I end up with 8 times x minus 2 on top. Again, it's multiplication, so the order doesn't matter. And then that's over 14x squared times x minus 2. And that becomes plus 9 times 7x, I guess I'll put that in parentheses, over 14x squared times x minus 2. And now we can distribute on top and get 8x minus 16 plus 63x from the other fraction all over our common denominator, which isn't changing. And then you can combine the x terms together and then be done. So you get 71x minus 16 over 14x squared times x minus 2. All right, so that one's fairly complex, but no given step of it, like mathematically speaking, is overly difficult, I don't think. Okay, now we have some subtraction problems. Now subtraction, you just got to be careful, and I'll show you where. But you start it the same way, so you factor everything. X plus 3, x plus 2, minus 2 over x plus 2. All right, so the second fraction is missing the factor of x plus 3. So multiply top and bottom by x plus 3. Okay, and that gives us 9 over x plus 3 times x plus 2 minus 2 times x plus 3 on top over x plus 2 times x plus 3. Again, these are the same, just written in different orders. That's okay. Now this one's going to be like, where did that subtraction one go? Up here? Right here. Remember when we had to distribute this minus sign to both of these and make it negative 7x minus 14? That's what's going to happen down here. And so when we write this as a single fraction, we get 9 minus, just put this in parentheses, this whole thing, because there's a minus sign. So I'm going to distribute at the same time and get 2x plus 6 all over x plus 3 times x plus 2, which is, now you can distribute the negative and make it negative 2x, and then it becomes 9 minus 6, so plus 3, all over x plus 3 times x plus 2. Okay, so exact same process as addition problems, just got to be careful with that minus sign at the end. All right, let's start this one the same way by factoring. Looks like this is going to be x plus 4 times x minus 3 minus 5 over, take it all to 12, and you get x minus 4. Okay, so now we have two factors missing. This has x minus 4, which this does, but this one doesn't have a 12 that this has, and this one doesn't have an x minus 3 that that has. So we multiply top and bottom of the first one by 12, and the second one by x minus 3. First one turns into 12x on top over 12 times x plus 4 times x minus 3. And then we have minus 5 times x minus 3 over 12 times, oh, hold on, I messed something up, sorry. This should have been x minus 4, x plus 3, thankfully, because otherwise this would have been way more difficult. That should have been x minus 4, yeah, x plus 3. That means these should just be x plus 3s right here, and that should be an x plus 3. So just change all these to plus 3s. change that. All right, and then we have our denominator is 12 times x. Oops, got to change this blue into a minus 4. 12 times x minus 4 times x plus 3. All right, so now our denominators are the same. And now you can combine these fractions into 12x minus 5x plus 15 when you distribute all over our common denominator, which is 12 times x minus 4 times x minus 3. And now distribute the negative on top and combine like terms, giving us 7x minus 15 over 12 times x minus 4 times x minus 3. And there you go. All right, last one. We're going to factor. Take out a GCF for that first one. Minus x plus 1 over. This factors into x minus 3 times x minus 1. Okay, so we have a same factor of x minus 1 already. This is missing a 2 that this has, and this one's missing the x minus 3. So multiply the first one by x minus 3 on top and bottom. Multiply the second one by just 2 on top and bottom. So now our first numerator becomes x minus 3 times x plus 2 all over 2 times x minus 3 times x minus 1 minus 2 times x plus 1 all over 2 times x minus 3 times x minus 1. Now when you get here, don't cancel things like we were doing in the last section. Like, we don't want to cancel these 2's. We just threw that 2 into the problem on purpose. So don't get rid of them right now. That would just go back to where we started. All right, so now we can... So we have to distribute the numerator. So I'm multiplying these two things together. X squared plus 2x minus 3x is minus x minus 6 all over our common denominator, which we don't have to multiply that. We just leave that in factored form. And then we have to distribute the negative. So you can kind of distribute negative 2 if you want to think of it like that. Turning the purple into, well, let's leave it like this, minus 2x plus 2 like that. Oh, we can write this as a single fraction actually. So minus like this. So we combine the numerators like that. Now distribute the minus sign. So there we go. And now combine like terms for our final step. So we have x squared on top minus 3x minus 8 all over 2 times x minus 3 times x minus 1. Okay, so none of the math is overly difficult on these problems. I mean, you got to be able to factor, of course, and you just got to be careful when you have to distribute the negative sign like we did here. And then just stay organized because they get kind of busy. Like there's kind of a lot going on here, but I think each individual step is very doable. And there you have it.